Hi everyone, I hope you are doing good. So today we will take a DSA questions which is related to array basically. So the question, let's understand the question first, and then we will discuss the algorithms, and then we will discuss the C++ code. Like we will implement the whatever the algorithm we discuss then into the C++. So let's start with question first. So the question is, we have given an array, right? We will get an array and then determine if there exists an element. We have to find an element in the array such that the sum of the elements on its left is equals to the sum of the elements on its right, right? So we have to find an element such that the left element sum and the right element sum of that element should be equal, right? And if there are no elements to the left and or right, then the sum is considered to be 0. So basically, so we have given one array, for example, 1, 2, 3, 3, right? So we have to find an element in this array such that sum of left elements and sum of right elements should be equal, right? So for example, here this 3, if we take this 3, right? So then sum of this left side elements and sum of the right side elements are same. See here, same, right? So we have to find if there is no such elements in the array, then we can say false, else we have to return true. So I hope you understood the question. It is very simple, right? We have to find an element such that the left element sum and the right element sum should be same, correct? So let's discuss the algorithms. Before that, you can pause the video and think about the solutions. What could be the solution here, and comment below the video so that we can also get to know what you are thinking. So let's understand the brute force approach first. So here what we will do, we will check for each and every element. We will calculate the sum of the left element, whatever the left elements we have, right? And we will calculate the sum of the right elements for particular element, right? So here what we will do, for example, we are start from 0, right? So for 0th element, what we will do, we will calculate the sum of the 0 to I minus 1 element, correct? And we will calculate at the same time sum of the I plus 1 to n minus 1 element, correct? So means whatever the element we will take, we will calculate all the elements sum left side one and all the elements sum right side one, basically, right? So this is our approach here, correct? So in case of I0, what we will do, from here left side, from 0 to minus 1, right? So here sum would be 0, correct? We can say sum would be 0 because no element is there left side. And here right side would be from 1 to right, the index here, the index is, let's take index here, 0, 1, 2, 3. So right side we will calculate from 1 to 3, right? From 1 to 3, and the sum is 2, 3, this is 8, correct? And left side sum is 0, correct? So now this is not our element, so we will check for the second here. So here I would be 1, right? In that case, the right side would be from second index, right, to index to 3, and the sum is here 3 and 3, 6, correct? And the left side would be 0 to n minus, like I minus 1, right? So that is 0, correct? Means only one element we have. So here sum would be 1. So 1 and 6 are not same. So we will check for the next element here, right? So here I would be 2. So in that case, right side we will calculate from 2 plus 1, that is 3, comma 3, right? From 3 to 3, that is here only one element, that is 3. So the sum would be 3. And the left side what we will do, from 0 to 2, right? So 0 to 2, sorry, 0 to 1, basically I minus 1, correct? So here 0 to 1 only, correct? So 0 to 1 we have two elements, 0 and 1, so the sum would be 3, right? And here check, after calculating the sum, we see 3 and 3 are same, so we can return this index, right? This 2 index. So we can return 2 index, or we can say, yeah, we found the an element for left element sum and right element sum is same. So this is the one approach. So here time complexity is order of n square. How is n square? You can see here we are iterating for each and element from 0 to n, right? So this is this is n, right? Order of n. And we are also iterating from 0 to I minus 1 and I plus 1 to n minus 1, right? So basically complete array we are iterating for each and every element here. right? So that's why it would be the time complexity, total time complexity would be order of n into n. Correct? You got it? Now this is the simple approach, right? Now if we want to improve this time complexity, right? So then how can we do that? So we have to optimize this algorithm so that we can achieve this result in order of n time complexity only, right? We have to iterate only once and then we should see the result. So that is what we have to think. You can pause the video and think about that solution.
3, 2, 1, go.
So let's see, I have added the algorithm here, optimized algorithm, where we will traverse the complete array and we will find the result. So let's do the dry run here first. So what I have added here, sum of all the elements. What we will do, we will calculate the sum of all the elements in one go. We can calculate the sum in order of n time complexity, correct? And then, so it would be in order of n, right? And then we will add one loop here, and I will calculate the left and right on the fly, right? While iterating the array only. So here it would be also order of n, right? And here what I am doing, I have taken one variable left, right? Which the value would be 0 initially, and I would take one element right? And the right value would be total sum basically, right? So right value, right is having the value sum, right? Whatever the sum we have, we have already calculated the sum of the array, so that is 9. So that's why I have taken here this 9, right? So it is sum basically, that is 9, correct? And here I will iterate the complete array from I equals to 0 to less than n, and here every time I am updating the right value and every time I am updating the left value, right? I will update the right value and then I will compare here, left and right should be same. If it is same, then we can return the result, right? We can directly say, yeah, we found the element, right? Else we will go and update the left value and then we will check for the next element, correct? So that is what I am doing. And if we do not find any element and such element in the array, in that case we will return, say, we can say here false, right? If we are out of this array and we did not find any element, right, in that case we can directly say false here. So let's do the dry run here for this given array. So here the index is 0, 1, 2, 3, right? So here left value, so let's this is I, right? And then we have this left value, right? And we have this right value, correct? So this is left basically. So this is left value, right? And here left initially is 0, right initially is 9, correct? I is 0, right? So now we are inside the loop here, and right we will update the right first. So right is equals to right minus a of I is 0, right? So a of I would be, this is our a array, right? So a of 0 is 1, so it would be minus 1, so that is 8, correct? And then we will compare left and right. So left and right is not same because left is 0, right is 8, correct? So we will go below and we will update this, we will execute these statements. Left is equals to left plus a of I, right? So here left would be left is equals to left plus a of I is or 1, right? So it would be, so here it would be 1, right? 0 plus 1, that is 1. Now we will go up and we will update here I, right? So now I is 1 here. Now again we will update the right here, right equals to right minus a of I. So whatever right we have, that is 8, right? So 8 minus a of I, that is 2, right? So here minus 2, that is 6. So right becomes 6, and now we will check left and right is same. No, it is not same. So what we will do, we will update left also. So left would be left plus a of I, right? So a of I, whatever we have, the a of I is 2, a of 1 is 2, so 1 plus 2, 1 plus 2, that is 3, right? So now we see left is 3, right is 6, and now we will go up and we will check we will update the I. So I here 2, right? I is 2, and now we will update the left and right here, right? So here right we will update. So right is equals to right, whatever right we have, that is 6, minus a of I, I is 2, right? So a of 2 is 3. So we will update this one, and here this is 3. Now this right is 3 and left is 3, right? So we will return from here. And what we can say, the element is at the index 2 is the such element, so that its left, some of the left element and some of the right elements are same. So this is very simple, just understand this one. So initially what we will do, we will initialize the right value with the sum of the elements of the array, correct? And each time, for each and every element, what we will do, we will subtract that element value from the right value, right? Whatever the right we have, we will subtract that value, that element value for particular element, right? And we will add that value to the left part, right? So basically we are subtracting from the right side and adding it to the left side, right? So left side will be will increase and the right side will be decrease, and we will each and for each and every element we will compare the value. If we find the left and right is same, then we can say that we found the result, right? Else we can say did not, right? And we can return the false. So let's look into the code and where we will understand this one. Yeah. So this is our main function, right? In main function, I'm just taking the inputs like the size of the array and array inputs and all those things, right? And here I'm calling this equilibrium. Equilibrium, this is our main function, which is where we have applied our logic, whatever we discussed here. What I am doing here, I am calculating the sum here, right? The sum we can calculate in order of n times. I am iterating through the complete array once only. And then what I am doing here, I am taking left and right, two variables, right? Right, I am initializing with the sum, whatever sum we have calculated already. And then what I will do here, I will update the right here. Right equals to sum minus ARR of I minus left, right? So this is one way, or it could be that right is equals to right minus ARR of I. So this is also work. Right is equals to right minus ARR of I. So here this would also work. So these are the two different ways of writing the or like achieving the same goal basically, right? So this is what we have discussed. So that's why I have updated this one here. And the left I will update left is equals to left plus error of I, right? And here we are comparing left and right, right? And if left and right are same, then we are returning true. Else we will return false. So let me build this code. So build is successful. Let me run this one. So it is asking for the input size array, right? So we have discussed the array of size 4, 1, 2, 3, 3, right? So let's 4, 1, 2, 3, 3. I have entered the array elements here and see here true. We found an element for which the left, some of the left elements and some of the right elements are same. Right? So let's take another example. Here we can take like the size of 1 only, right? And the element could be, for example, 1 or whatever the value you have, 5, right? So it would give the true. Why true? Because we have discussed, right? The rule is, they have mentioned here clearly, if there are no elements to the left or right, then the sum is considered to be 0. So in this case, what we are doing, basically the left elements, we do not have left elements and we do not have right elements because we have only one element. So left and right would be considered as 0. That's why we are getting the true here, correct? And if we take two example, for example, we have an array of 2, right? 1 and 2, right? So this is giving false. Why false? Because 1 for whenever we check for 1, then left is 0, right is 2, correct? So both are not same. Then we will check for the second here. The second, left is 1, right is 0. So both are not same. That's why we are getting false here, right? So each and every use case, corner case, or code or algorithm will work, right? I hope you got the algorithm, you got the you understood the logic, right? So let me come out from here. So I have explained you the brute force, right? The simple logic, where we that would be the time complexity of order of n square, right? Then each and every time we will calculate in the left and right, the sum of the left elements and sum of the right elements. And here we are calculating left and right on the go while iterating through the complete array only, right? So this would be your order of n optimized algorithm, right? So I hope you understood this. Yeah, that's all from my side. See you next time. Till then, keep learning and keep exploring.